Alright, we're looking at the disambiguation page for Wikipedia for vectors, and my goodness, there's a number of entries here. I can understand where there would be ambiguity. Let me dispel that ambiguity without you having to read a damn thing. Today's video is about vectors. Okay, so we know the basics now of variable assignment, but I'm sure you've quickly realized that if we can only store one number in each of our variables or one value of any sort in each of our variables, things are going to get very tedious very quickly. So we're going to look today at how to create vectors within R. Vectors are the most basic type of data structure in R that you can use to contain multiple values. And so I've got A and B and C and D here stored, and if I wanted, I could take a look at them. You can see, A is equal to 1, B to 2, C to 3, D to 4, and so on. I could make a vector to store all of those values. Let's make E, and I'm going to use this particular syntax to begin with, 1:4, and then let's take a look at E. So E is 1, 2, 3, 4. Now that's a one sort of shortcut for creating a sequence of integer numbers. You can use just the colon in that case. A more traditional way to create a vector would be to do something like E equals C, and the C function you can think of as concatenate or combine. What it does is it takes individual elements up, sews them into a big vector together, so we can do C, A, B, and let's switch C and D here. So we'll go D first and then C. And you'll see that the order that you put these things in matters. So I'm going to evaluate this, and then we're going to go ahead and look at E, and it's now 1, 2, 4, 3. So that C function is another way that you can take things and make them into vectors. Now vectors do not have to be retrieved like this all at once. If you want to look at just a part of a vector, you use square brackets after the variable to which the vector is assigned to look at a portion of it. So if I want to look at just the second item in E, I would type E square bracket 2 and then close the square bracket. Let's evaluate that. Of course, the answer is 2. The third item in E, though, is 4, and you can see how that maps on. Let's see if I just wanted to look at the last two items. I do E3:4 here. 4 and 3 is my result. You can even subset a vector by another vector. So let's give F the value of 2 to 4, and then let's look at E subset to F. And we're going to get 2, 4, 3, which are the second, third, and fourth items of E. Not too terribly complicated. Now you'll notice there's a 1 that prints out in the console here anytime I get output. And you've been probably seeing that throughout all these videos. I'm going to show you right now what that is. So let's now take G and give it a vector of 100 numbers. The number is 1 to 100. And then we'll go ahead and tell the console to print it out for us. And what we get is the numbers 1 to 100 printed out here, but you'll see that this 1 now is 19, now is 37 and 55. That is telling you, when you're looking at that row of numbers in the console output, which position in the vector you're looking at for the first item in that row. So 1 is the first number in the series, 19 is the 19th number in the series, and so on and so forth. Now that's a pretty intuitive case there, but it's more useful when they don't map onto each other 1 to 1. So let's make G 100 to 200, and then we'll take a look at it. And you can see those row numbers are more useful in this case. The first item is 100 and the 55th item is 154. So depending on how many characters of screen space those things are taking up in your console is going to depend, is rather going to be the determining factor of how many rows you get. It's not regulated by anything other than how much console space it has to work in. Alright, so those are some very basic things on vector construction and vector indexing. Let's take a look for a moment at operating on vectors. Let's make E equal to 1 to 4 again. So get that down there and run it. And let's take a look at E one more time just to make sure we know what we're dealing with. Dealing with 1, 2, 3, 4, pretty simple stuff. Now let's evaluate E plus 1. And what it's done is it's added 1 to each item in E. So we have 2, 3, 4, 5. Let's try E multiplied by 5. And just like it did with addition, it's applying multiplication across the board. Let's try E squared. So you can see pretty clearly what's happening is when you apply a mathematical operator to a vector, what it does is it applies that to each individual member of the vector. Let's try adding E to E. And if we look here, you can see what's happened is it's taken 1 to 1 and added it to 1 to make 2. 2 plus 2 is 4. 3 plus 3 is 6. And you see what's going on there. So it does the same thing with multiplication, or the same thing with an exponent here. Now, if we take a couple steps back, you might have hoped that e plus e would yield you a vector of length 8 that went 1, 2, 3, 4, 1, 2, 3, 4. That's not how vector addition works in R. What you need to do to make that happen is to use the C function again. So let's say C, E and E here, and that's exactly what we get. So those are the very basics of working with vectors. There's a few other tricks and subtleties you can employ. We'll kind of visit those as we need them along the way. As we move forward here, we're going to start working with more and more complicated data structures. We're getting very close to the point where we can start pulling in data and doing some more exciting things with it. So again, this is Ed from my Bring Back. Thanks for watching these videos, and keep coming back.